Assalamualaikum. My name is Dania Azam and my roll number is 16T95. Today I present my project, a robust single-shot person re-identification system for public safety and applications. The outline of the project are as follows. First, we have introduction. Then we have problem statement, aims and objectives, literature review, methodology of our research paper, applications of our research paper, and then we have references. Now, what is the person re-identification? Person re-identification is basically recognizing a person in the diverse location over the different non-overlapping cameras. In this figure, we have camera A and the camera B, which are non-overlapping cameras, and we have to identify this image in all of these images. But in the processing of the person re-identification, we have two sets. One is the probe set and the other one is the gallery set. Probe set contains the target image and the gallery set contains all the instances of the person. Problem statement: the person re-identification faced the many challenges such as the illumination, changes in the indoor and the outdoor environment, viewpoint, pose, clothes, as the clothes are uniform in the city and the construction site area, so it is difficult to identify the individual from the multiple camera views. So to overcome this problem, we choose the best combination of the feature extraction technique and the metric learning technique through the handcraft, so to that provide the better matching accuracy. Aims and objectives of the project are as follows: development of the fast human detection system for the public safety applications, development of the robust texture and the color descriptor, development of the feature extraction algorithm that is independent of the dataset by using the handcraft technique, and then we select the best combination of the metric learning and the feature extraction method that provide us the higher performance. In the literature review, the basic concept is that we have the two images. This one is the gallery image and the other one is a probe image. The probe image is the target image. After the pre-processing of these two images, we extract the features from these two images and then calculate the distance. The image which has the least distance the image which has the least distance has more similarity, and vice versa. In this way, we identify a certain person. In the related work, we combine the two features extraction technique, feature extraction and the metric learning approaches to get the higher rank by using the single shot and the multi-shot ranking. And we use the classifier KNN, kernel nearest neighbor. Proposed descriptor is Gaussian of Gaussian. In the Gaussian of Gaussian, we have regions, and then each region are described as the local Gaussians, and each of the local Gaussians contains the region which we extract the features and combine into one vector. The methodology of our research are as follows. In the sample, we have two images. One is the probe and the other one is the gallery. Then we extract the features by using the KNN, kernel nearest neighbor, and then we calculate the distance by the NFST technique. This is the best technique and gives us the highest accuracy on the rank 1, 5 and 10, and then we calculate the distance of these two individuals feature extractors, and then take the average and get the result. The initial ranking is 41.2%, and as you see that the proposed ranking list is 47.64. The results are shown as are below. Here we have the highest accuracy for the metric learning technique for the NFST, null, Foley, stem and transfer for the rank 1, 5 and 10. The graph, these results are shown is in the form of a diagram. Here on the x-axis we have metric learning, and on the y-axis we have accuracy, and the graphs are shown below. This graph shows that which metric learning technique have the highest accuracy. Proposed method, here we have the data set VIP-ER. VIP-ER contains the 632 people from the two different view, and each person has only one camera. We use the descriptor GOG, Gaussian of Gaussian, and applying the metric learning technique, and we have the different accuracies. The best highest accuracy is 41.1 for the cross-view quadratic discriminative analysis for the data set VIP-ER. Final year project. In the progress of our project, in the month 1 we installed the MATLAB, then know its basics, we read out the research papers and know the difference between the handcrafted and the convolution networks. In the convolution network, we extract the feature directly from the images, while in the handcrafted, we don't extract the features directly, but we have to know all the algorithms, and the information is based on the image itself. And in the month 2, we again started from the handcrafted, then do the feature extraction, metric learning, and represent the feature that the feature extract is in the form of an histogram. In the month 3, we arranged the data sets, worked on the data sets, and combined the best combination of the feature extraction and the metric learning technique and implemented. In the month 4, we improved the accuracy up to 47.64. Then we wrote down the introduction and the literature review of our research paper, and we requested for the multi-shot dataset. The applications of our research paper is that it is used in the surveillance and the security concerns to track the suspect of the crime scene, tracking the multiple camera, that is to identify the certain person. Safe city project, it is which the best motivation we get that it is to choose this project is that it is a safe city project. In the Islamabad and the other cities, almost 10450 cameras are installed on the different places, are also used in the forensic and the biometric applications. And here are the references. So this is all about the project. Thank you very much.